pressure in fluids. Pressure in fluids. Okay. Now see, all of you, read your this one book. All liquid gases are fluid. Have you seen the paragraph? Pressure in fluids. Page number 139, the last para. Have you seen? Yes or no? Have you seen? Yes. Navo, দেখা হৈছে?
Yes, sir. Oh, sir.
So it is for me. See the paragraph. All liquids and gases are fluids. That means fluids are two types. One is liquid and one is gas. A solid exerts pressure on a surface due to its weight. Similarly, fluids have also weight, and they also exert pressure on the base and walls of the container in which they are enclosed. So first, I don't like this. Fluids. Two types of fluids. One is your liquid and one is your gas. So write down in a copy, all of you. Fluids are two types. One is your liquid, one is your gas. So now see, suppose a solid exerts some. Suppose if you put a suppose book. If you put a book on a table, the book will exert some what? The book has some weight, yes or no? The book has some weight, and due to the weight, it exerts some pressure on the table. Clear? This one? The book has some weight, and due to this weight, the book exerts some pressure on the table. Similarly, fluids have also weight. Solid, this is solid. Solid have some weight, and due to this weight, it exerts pressure. Solid have some weight, and due to this weight, it exerts pressure. Similarly, liquid and gas also weight, and due to this weight, it exerts some pressure. Okay. So that's why fluid have some weight. So, and they also exert pressure on the base and the walls of the container in which they are enclosed. In the next page, pressure exerted in any confined mass of fluid is transmitted undiminished in all directions. That means, suppose when a suppose beaker is full of your air. Suppose a beaker is full of air. Now this air will exert pressure in all the direction. This air will exert pressure on all the direction. That means in all the direction of the inside the beaker. Yes or no? Why it exert pressure? Because it has some weight. That's why it exert pressure. All of you clear this one? Yes or no?
Yes, sir.
Okay. Response me quickly. Now see. So that's why fluid has some weight, and due to this what? Fluid has some weight, and due to this weight, the fluid exerts some pressure. Okay. Now all of you see the next topic, buoyancy. All of you now see buoyancy. What do you mean by buoyancy? I have already given you the definition of buoyancy. Have you written in your copy? That is in the PDF. I gave you the definition. The definition is an upward force exerted by a fluid. An upward force exerted by a fluid that opposes the weight of an immersed object is called buoyancy. So an upward force exerted by a fluid that opposes the weight of an immersed object is called buoyancy. Now see, what do you mean by buoyancy? Suppose this is water. Have you ever experienced it? Suppose take a bucket of water and then you dip the mug into the water. So, do you feel an opposite force? Have you ever feel the opposite force coming upward? তোমালোকে ফিল কৰিছা নাই? Suppose তুমি এটা বাকেটত water ললা আৰু মগটোৱে তুমি water খিনি তুমি মগটো ডুবাই দিলা। ডুবাই দিয়াৰ লগত কি হ'ব তুমি চাবাচোন এটা আপওয়ার্ড ফোর্স এটা ফিল কৰা নাই? কৰা? So সেইটো হ'ল তোমাৰ buoyancy. An upward force exerted by a fluid that opposes the weight of an immersed object is called immersed object. Means jeta dubai diba immersed object. That means when you immerse a object into the water and up into the water, now see the immersed object has some weight. So an upward force will act. Upward force will act. Yes or no? An upward force will the upward force will be exerted by the your fluid on the body, and this force is known as your buoyancy. Clear, all of you? Clear is a buoyancy ki hoy?
Yes, sir.
Now see PDF of mata I have given you one note. The force acting vertically upward on the body immersed in liquid is called upthrust or buoyant force. Now see, the force acting vertically upward on the body immersed in liquid is called upthrust or buoyant force. That means when you immerse a body, suppose this is a bucket of water, and when you immerse a force acting vertically upon a body, suppose a body is immersed in the liquid, so a force will act upward, and this upward on the body, and this upward force is known as buoyant force. This upward force is known, or actually buoyant force or upthrust. This upward force is known as 1 minute. Yes or no? So this is the Archimedes principle. If a body is wholly, I will explain. First, see the definition. If a body is wholly or partially immersed in a fluid, if a body is wholly or partially immersed in a fluid, it experiences an upthrust equal to the. It experiences an upthrust equal to the weight of the fluid displaced, and this upthrust acts through the center of gravity of the displaced fluid. Now see, suppose a body, suppose take a beaker, and suppose take a beaker, and suppose this is the one passes of the beaker. That means water can pass through this capillary. Now see, suppose water is in this level. Suppose water is in this level, and place a smaller beaker here. Now see, water is below this level. This is the your one capillary structure is here, and water is below this one. Below the level of the water is below this capillary structure. Now what happened? Now when you deep or when you throw, suppose when you throw a stone, when you throw a stone into the water, when you throw a stone into the water, what will happen? কি হবো? Anyone? নব কি হবো? Anyone? কি হবো? When you throw a stone into the water, what will happen? Some amount of water will come out. Some amount of water will come out. Okay, some amount of water will come out. Why? Because of this Archimedes principle. Now see, some amount of water is come out. Huh? Yes. And see, now see, when a body is wholly or partially immersed in a fluid, it experiences an up. Now see, when you immerse the stone in the water, what will happen? An upward force will act on the stone. An upward force will act on the stone, which is equal to the, and it experiences an upward force which is equal to the weight of the fluid displaced. That means when you immerse the stone into the water, an upward force will act. That means this is the buoyant force which will act on the stone, and this upward force will be equal to the amount of water displaced by it. Now see, when you throw the stone into the water, some amount of water will flow. Yes or no? This amount of water, the weight of this amount of water which is displaced by the stone will be equal to this upward force. Clear, all of you? This one? Clear or not?
Sir, yes.
Yes. Response me. So Novo clear? This one? Novo? Okay.
Yes, sir.
Okay. So, what is the Archimedes principle? If a body is wholly means fully immersed wholly or partially means half of the body. If you immerse a stone or body, when you immerse any body wholly or partially into the fluid, suppose it's a water, it can be any fluid, into the fluid, then upward thrust, which is known as buoyant force, upward thrust will act on the stone or the body, and this upward thrust will be equal to the amount of water displaced by the amount. Then upward thrust will be equal to the what? Weight of the fluid displaced by the stone. Clear, all of you? This one? বুঝিয়েছা? This is known as your Archimedes principle. So what is Archimedes? Again, I will repeat. When a body is wholly or partially immersed in the fluid, then the body will experience an upward thrust, and this upward thrust will be equal to the weight of the liquid or weight of the fluid displaced by the body. Okay, and this upward this one displaced, and this thrust up thrust act for the center of the gravity of the displaced fluid, and this upthrust, that is upward force, will act on the center of gravity of the displaced fluid. The amount of fluid which is displaced by the stone or the body, the amount of fluid which is displaced by the stone or the body, the center of gravity always present in the middle of the body. Center of gravity, the upward thrust will act on the center of through the center of gravity of the fluid which is displaced by the body. Clear, all of you? Archimedes principle. Raise your hand. Clear. If you have any network problem, just raise your hand. Clear, sir. Okay. Clear?
Yes, sir. Sir, yes.
Okay. Now see, this is the very important Archimedes principle. Now see this one. It is given in your NCERT book also. See the page number 142. See the page number 142, first para. When a body immersed fully or partially in a fluid experiences an upward force that is equal to the weight of the fluid displaced by it. This is the Archimedes principle. Now see relative density. What do you mean by relative density? See the next topic, relative density. All of you see the next topic, relative density. Relative density. We have only 4 minutes left. So what do you mean by relative density? See the definition. I have given in your PDF. So the relative density of the substance is the ratio of its density to that of the water. Now see, the definition of relative density is that relative density of a substance is the ratio of its density to that of water. So relative density of a substance is the ratio of its density to that of water. So you can write like this: relative density equal to density of a substance by density of water. Now see, so relative density is known as the ratio of the density of a substance to the density of the water. So since it is the ratio of the density, so it has no unit. Why? Because since the relative density is the ratio of the similar quantities, here also density, here also density. So it has no unit. Actually, the your unit of density is your kg. What is density? Density is mass by volume. Density is mass by volume. So the unit of mass is kg and volume will be meter cube. So kg per meter cube. This is the unit of density. But it is the ratio of the density. That's why kg per meter cube by kg per meter cube. So this will cut out. This will get cancelled. That's why relative density has no unit. So that's why in your exam it will be asked that relative density does relative density has unit? So it has no unit. Relative density has no unit. Clear, all of you? Clear?
Sir, yes.
Okay. So this will end our chapter, gravitation chapter. So see the example. We have only 1:10. That means 1:10 minutes left. Now see example 10.7. Relative density of the silver is 10.8. The density of water is 10 cube kg per meter cube. What is the density of silver in SI unit? See the NCERT book. So very easy. The density of silver is given. Relative density will be density of silver by density of the water. So and you have to remember density of silver and density of water. Sorry, density of water you have to remember. Okay. Now see in your NCERT book, see this one. See the first pair 10.7 relative density. It is given. Density of water is 1000 kg per meter cube. You have to underline this one. So you have to put the value and you can find the density of silver. Okay. So we will end the class here. Tomorrow again we will meet same time. Okay. Same time or 3 we can meet at 3 p.m. Okay.
Okay.
Thank you.
Bye.